Okay, so as far as your homework from last time, are there any questions?
No, sir.
No? Anyone want me to go through any of the problems or take a look at anything? We're okay? All right, well, in that case, let's go ahead and get started with, we'll continue with what we were doing last time, and that is order of operations. And we had started working, I think we did the first two problems here. Yeah, we had done the first two, but we hadn't gotten through, you know, the good variety we have here. So let's go ahead and look at number 3, just to kind of get us going. So number 3, we have the square root of 5 squared minus 3 squared. Now, there's a couple of important things that we need to understand about this expression. First of all, we all need to understand what this symbol, square root, means. And I'm going to assume that you have seen it in the past. All it is another way of saying, let's say we have the square root of 4. All this is saying is, can you think of a number that when you multiply it times itself, you get 4, all right? So the answer here would be 2, because 2 times 2 will give you back the 4. And we have some other ones that you should know. Square root of 9. Well, the number that you multiply times itself to get 9 would be 3, right? 3 times 3 is 9. And there's common ones that we call them the perfect squares. What would be the next one that we should know? What would be a square root that you would be able to think of off the top of your head?
16.
16, okay, square root of 16 would be 4, right? Because 4 times 4 gives you 16. And we could keep going here for a bit. 25 would be the next one. Now, we have to also keep in mind that sometimes there are square roots that we don't know the answer. So like if we just go square root of 10, nobody's going to be able to tell me what that answer is without a calculator. So everyone needs to make sure that on their calculator, they know where the square root key is and that you can do the square root. So if you have your calculator, take a moment to do this. I'm assuming you'll be able to find that key. You should get something. I'm going to put a squiggly equal sign. That means approximately. So it's approximately 3.16. And my calculator keeps on going with more numbers, but we're just going to round 2 decimal places. That's it. Okay, so the square root symbol is basically telling you need to come up with a number that when you multiply times itself, you get that number that's underneath that square root. Also, the number underneath here, the 4, the 9, the 16, the 25, the 10, there's a name for those numbers. Anything that's underneath the square root is called the radicand. It's kind of a weird word. It's called the radicand. So, you know, if we say, hey, you know, look at this one, what's the radicand? It's 9, okay? All right, so that's just some language. The other thing we have to be kind of aware of here, and I'm going to give you a different example. I'm not going to look at number 3. This is a very common mistake that students make. Okay, so I'm going to separate this. Let's say we have the square root of 9 plus 4. Okay? What students will do is they'll say, oh, well, I know what the square root of 9 is. It's 3. And I know what the square root of 4 is. It's 2. And so they'll say, oh, this is the same as just taking the square root of 9 and adding to it the square root of 4. And the square root of 9 is 3, and the square root of 4 is 2, so my answer should be 5. Do you see what I've done here? It's not correct, but that is a common mistake that students make. And you can convince yourself that this isn't true by just figuring out what is 9 plus 4, right? 9 plus 4 is 13. So is the square root of 13 5? It shouldn't be, right? The square root of 25 is 5. So this is wrong. So what I'm getting at is if you have addition or subtraction underneath the square root, you may not split it into two. That is illegal, all right? Now, another thing that students need to be clear of is there is an incident where you can do it, but here's what it would have to look like. Square root of 9 times 4. So notice I changed the operation between the 9 and 4. I changed it to multiplication instead of addition. Here, you can do the square root of 9 times the square root of 4. That should give you 3, because square root of 9 is 3, and the square root of 4 is 2. Our answer should be 6. And we can check that by just thinking about what 9 times 4 is. If we were to just have done this, 9 times 4 is 36. And the square root of 36 is 6, right? So it does work whenever there's multiplication underneath the radical, but it does not work when there's addition or subtraction. Okay, so just be careful with that. And then last thing is when you see a radical or a square root, we want to treat it like a parentheses. So you know order of operations, we say parentheses, exponents, multiplication, division, addition, subtraction. Always treat a radical like parentheses. Okay, so with all of that said, let's go back to this. So right now, we are not allowed to split this into two, right? We cannot split this into like the square root of 5 squared minus the square root of 3 squared. That is not allowed, right? No. So our only real hope here is to just simplify what we see. So I'm going to just do the operations underneath the radical. So it's almost like the radical is a parentheses, and I'm working inside the radical right now. I'm just going to figure out what this is. And in there, I see exponents, right? I see things raised to powers. So I'm going to just go ahead and take care of those. 5 squared is 25, right? Minus, and I'm going to go ahead and square the 3, that's 9. And now I just do the subtraction. 25 take away 9. That should give me, what, 16? And now, do we know what the square root of 16 is? That happens to be one that we should know, right? 4, so we just put 4. There it is. Okay, so even though this is a pretty like simple problem, there's a lot of little like ancillary things here on the side that I just talked about that we just need to be clear about as we move forward. Okay, let's take a look at number 4. Yeah, I have enough room here. Okay, so number 4, we have this weird, that's like a bar, and we'll talk about what it is in a minute. 4 minus 8, and then the bar again, then minus 9, and then dot, and then 2 minus 3 in parentheses. Okay, so let's first understand what that bar means. So when we have this bar around a number, let's just call that number x. This is called the absolute value. Of x in this case. And all the absolute value does is it just takes whatever's inside and it just spits out the positive answer of whatever's inside. So if you say, okay, what's the absolute value of 4? The answer would be, well, it's whatever's in here, whatever number's in there, but the positive version of that number. But 4 is already positive, so the answer is just 4. If we have the absolute value of -4, then we look at the number inside -4 and we say, oh, just make that a positive number. And that's your answer. So the answer would be +4. So it basically eliminates any negative signs. All right, that's all it does. And if you want to think about it, you can actually kind of understand what absolute value is if you think of a number line. When we took this first example, 4, if we were to plot 4 on a number line, what the absolute value is actually doing is measuring the distance from 0 to that number. So it's like if you got a tape measure and measure that distance, it would be 4. If you take the other number, -4, and you put that on the number line, 1, 2, 3, 4, here's -4, and you measure the distance from here to here, that would also be 4, like if you had a measuring tape. So that's all the absolute value is doing, is measuring the distance from 0 to that number. So it always spits out a positive answer. Okay, so the other thing we need to know is that you treat an absolute parentheses, all right? So if you see an absolute value, you want to do what's inside of it first and then do the absolute value. So looking at this expression, we have the absolute value here. Okay, so we got to do what's inside that first. And we have another set of parentheses here that we have to do what's inside of that, right? So the order in which you do this doesn't matter. You can do what's in yellow first and then do what's in green, or you can do what's in green and then do what's in yellow, or you can do them both at the same time. I'm going to kind of save us some time and I'm going to do them both at the same time. So I'm going to rewrite the absolute value bar. And now I have to figure out what 4 minus 8 is. And I mentioned this last class, that this whole thing with sign numbers, everyone in the class is at a different place, okay? So 4 minus 8, let's see, who's on my list today? I need to talk with Sebastian, Samantha, Emily, Ashlyn, Justin, Jesus. That's the order that the first few I'm going to call on are. So we'll start here with Sebastian. Sebastian around today?
Yes, I'm right here.
Oh, there you are, Sebastian. How you doing?
Pretty well. How about yourself?
I'm doing okay, doing okay. So how do you feel about the sign number 4 minus 8? Is that something you're comfortable with? Or are you gonna, yeah?
Yes, sir. It's -4.
-4, okay. So we're gonna have a -4 in here. All right, let's just keep writing. -9 times, how about Sebastian, this 2 take away 3?
-1.
-1, okay, good. All right, so we have done what's in the parentheses, right? Now we need to actually do the operation. So we need to actually do the absolute value, right? The absolute value of -4. So moving along here, I said Samantha's up next. So Samantha, how you doing?
Good.
Good. Okay, good, good. So absolute value of -4 would be?
4.
4, okay. And then what do you want to do over here? I mean, you can't really do anything else with the -1, right? I mean, it's there.
Mm-hmm.
But we do have an operation. We have a subtraction and then we have a multiplication. So you're going to do which one first?
Multiplication.
Okay, multiplication. So how do you want to do this? You've got to somehow multiply. So what are you going to multiply? Like, what are you thinking you're going to multiply together?
9 by -1.
9 by -1. Okay, so you've decided, and this is correct, to just keep this minus sign here.
Yeah.
Right? And then you're going to put these two together and you're going to do 9 times -1. And what does that give you?
-9.
-9. So we have to be careful here. I'm going to actually, I don't want to write -9 like this. That's bad notation to have a minus minus right next to one another. So I just throw it in parentheses. Now, Sammy, do you want me to change it to Sammy on my thing? Or?
Yeah, that's fine.
Okay. So Sammy, do you, how do you combine those together? When you have a minus minus, what does it become?
Plus.
Plus. It's a double negative. Double negative becomes positive. That's like me saying, I don't like donuts. That means I like them. Okay, so that's called a double negative. So I'm going to add 9. And then finally, that just gives us 13. Okay, are there any questions on that? All right, let's get some of this other stuff involved here, or these other problems. Some of these things with fractions, that always causes problems. And before I actually start one of these, I want to write something down and I want to see what y'all come up with, okay? And maybe I'll do a vote here on what the answer is. So I'd like to do 12 divided by 2 divided by, you know what, let's make that not a 2, let's make that a 6 divided by 3. Okay, there we go. 12 divided by 6 divided by 3, written like that. So I want you to think about what this is. Like, what number does this turn out to be? All right. So to give it a moment, I'm going to give you a couple of seconds here to kind of think about it. And then I think I'm going to ask Emily, which isn't really fair. So Emily, is Emily here? Yeah, Emily's here. So Emily, I'm already saying that this is not a fair question. So it's very likely you're going to get it wrong, but it's okay if you do. All right. So Emily, do you have an idea of what you think this might be?
No, I have no idea.
Okay, so did you try doing anything? Like, just do something, like just pick something to do and tell me what you're going to do.
Well, when I first looked at it, I thought of just going in order, like 12 divided by 6.
Okay, so let's do that. Okay, let's do the 12 divided by 6. That sound fair, everyone? 12 divided by 6, that would give you 2, wouldn't it?
Yes.
So you'd have a 2 on top. Now you still have to take that and divide that by 3, don't you?
Yes.
Okay, so that would be one answer, 2/3. That's an actual number. You could get on your calculator and figure out what that is, but that's one possibility. Another possibility would have been what, Emily? You could have done, you decided to do 12 divided by 6 first, but you could have done what?
The 6 divided by 3.
Yeah, you could have done the 6 divided by 3 first, right? In that case, you would have got 2, and you would have had 12 over 2, and that would have been 6, right? So those are the two answers that could have been possible here. And like I've stated before, we can't have two different people getting two different answers, especially if you're building bridges or airplanes, right? So there's something wrong in the way I presented the problem. I intentionally wrote it because it's confusing, but the way I wrote it is considered to be bad notation. So I should have done something like this. If I wanted you to do this one up here, I'm gonna have to do it to the left. I can do it to the right. If I wanted you to actually do that one, which means the 12 divided by 6 first, then I should have written it this way. 12 divided by 6 divided by 3. What's the difference?
It prioritizes the 12 divided by 6 first. And
By
then
doing
you
what?
would,
What did I do to make you know that? Like, what's the change in the notation?
The line is smaller.
That's right. It's the size of the line. It's actually, so this is a subtle thing, but it's the size of that line. This big division right here, that big bar, means that you're going to do everything up top first and then everything on the bottom and then put them together. See, on this one, if I wanted you to do it this way, I would have written like this: 12 divided by, and then 6 divided by 3. You see that? See the difference between those two? Okay, so like I said, in the beginning when I gave you the problem, I gave you the problem in this form, and that was me intentionally not giving you a long bar to see if people would get two different answers, which is normally what happens. So you have to have that bar, the long bar, to separate things. And you can see that if you look over here on our homework assignment. If you look at number 10, do you see that you've got some fractions up top, right? You've got some fractions up top, and then you have this long bar. Also here in number 9, you got this long bar. The long bar means you separate. You do everything up top, everything on the bottom, finish doing all of that, and then you put them together, all right? Okay, so let's get back now. Let's look at number 5. So number 5, you have 7 raised to the 3rd power plus 2 parentheses 4. That means 2 times 4. And then you have 17 minus 3. So like I was just saying, that long bar means that we have to basically do everything on the bottom, everything on the top. And once we're done, then we combine them. So you can almost imagine there's like a parenthesis around everything on top, parenthesis around everything on bottom. You have to completely finish those out before you actually do the division. All right, let's crank through people here today. My next, Ashlyn. Is Ashlyn here?
I'm here.
Okay. Oh, there you are. Okay, Ashlyn. I haven't called on you before, have I?
No.
No. Okay. All right. So Ashlyn, go ahead. What do you want to do?
I want to multiply the 7 times its exponent.
Okay. So are you going to do 7 times 3, or are you going to do 7 times 7 times 7?
To the exponent of 3.
Yeah. Okay. So do you have a calculator?
Yeah, I do.
You got it?
It's 343.
343. Okay. So 343, and then plus. Now, Ashlyn, do you want to go ahead and just do this operation right now?
Yeah.
Okay, so 2 times 4, that's 8. And on the bottom, this is pretty straightforward. There's not a whole lot going on here, right? 17 minus 3, it's just 14. You add on top, right? So here's the thing, you have to add everything up first. So we're gonna have 351 over 14. Okay, now at this point, I would just get on the calculator and figure out what that is. So Ashlyn, do you have this? Did you get an answer here?
Yeah, it's supposed to be 25.07.
07. Okay. So we'll just, again, we're just going to round 2 decimal places. Did everyone get that? Yeah. So on a test, I would take this answer or this answer. I would take them both, either one. Okay. You don't have to go to a decimal.
Would you take a mixed number?
Oh yeah, you could do a mixed number, but that's more work. You know, it's more work. So I wouldn't. I don't know. I may have mentioned this before, but mixed numbers are kind of like, I think I did mention this. Like when we write a number, let's just say we take the number like 8/3. We could write that as a mixed number as 2 2/3. But it's kind of like when you're first learning math and they teach you the division symbol and then they teach you the multiplication symbol, right? And you use these are like the ones you learn in like grade school. And then later on, division really becomes just like fractions and the multiplication becomes dots. So like later on in math, we stop using the mixed numbers. It's kind of like too elementary, and we'd prefer to work with the improper fraction instead. Like if you, I know y'all aren't going to do this, but in calculus, we never ever write numbers as mixed numbers. It's always fractions. So we just kind of like get rid of it. So, but if you want to, you can, all right? It's not incorrect. It's just, again, another layer of work that you would have to do to convert it. Okay, let's see. Now we can't do all of these. So let's see who's up on my list here. Jesus, is Jesus here?
Yeah, I'm here.
Okay, there you are. Have I not called you either? Thought I had. No,
You called me last week.
I did. I didn't mark you down. Okay. Well, Jesus, you pick one of these. Can you see the problems well enough?
Kind of. I don't know. I'll do one.
Pick something that doesn't look like you want to do it. Like pick one that looks scary to you.
Number 6.
Number 6, yeah, that one does look kind of bad. Okay, so we've got what this is actually referred to as a complex fraction. It's fractions within fractions. So we have 1 plus, and then we've got this division bar. Then we've got 2/3, and we've got 2/5 plus 1/3. Okay, so Jesus, I'm going to slap a set of parentheses around the top. And I can put them on the bottom if I want, but that's just to kind of stress to you that you have to do all of the stuff on top first and all on the bottom. So Jesus, when you're looking at that, the top and the bottom, which one looks easier for you to do just right off the bat, just to kind of get it done? The top or the bottom?
Bottom.
The bottom, right? I agree. So I'm just going to rewrite it. And then 2 cubed means, what is that, Jesus? Is that 6 or something else?
That's 6.
Is it? What does 2 cubed mean? Means 2 times 2 times 2, right? And that should give us 8. So just be careful. I intentionally tried to trick you because that's, again, a common mistake. People would just kind of forget. We're not doing multiplication, we're doing exponents. So 2 times 2 times 2 is 8. All right, Jesus. Now you have no choice. You have to do the numerator. So in the numerator, what do you see, Jesus? What are we trying to do here?
Trying to add them.
Add what? You're trying to add what together?
The fractions together?
Fractions, okay. Do they have the same denominator?
Negative.
They do not. Okay, so we've done this though, right? We've actually done addition of fractions with different denominators. And I actually showed you all a shortcut, and I think a lot of you liked it. And the only drawback to it is that you might have to reduce the fractions. So I'm gonna do this on the side. I'm gonna go 2/5 plus 1/3. So this is like scratch work. And do you remember the procedure here? I'm gonna move on, Jesus, I'll cut you off here. Let's go to Justin. Yeah, I think Justin's up. Is Justin around?
Yeah, I'm here.
Okay, there you are, Justin. So Justin, do you remember the little thing we do here to multiply 2 fractions with different denominators? Or not multiply, to add 2 fractions together with different denominators?
Find the LCD.
Okay, so we could do that, but the shortcut way, do you remember when we just like multiplied these two? 2 times 3, that gave us 6. And then we put plus. Does this look familiar? Then those two together, 5. And then over these two multiplied, 15. So if that doesn't look familiar, the look on your face makes me think that doesn't look familiar.
Was this what we did towards the back half of last class? Because I got pulled off of the computer, so I had to step away. And by the time I came back, class was over.
I don't know.
So I may have missed it.
Yeah, I don't remember if it was at the end of last class. I think it was a class before, but either way, okay, either way, if that's not fresh in your mind, you should probably, everyone, you know, if anyone's looking at that and can't remember how to add 2 fractions with different denominators, you need to make sure that you've got that kind of like hardwired, that you do the little diagonal thing and then you do across the bottom, because that's a very fast, efficient way of adding fractions. So we should get 11.
11 over 15, okay.
Yeah. Okay, so I'm going to rewrite everything. 1 plus, on top we have 11 over 15. We have this big bar, and then we have an 8 down here. Okay, we are at a very interesting point right now. So we are going to move on to...
On your rewrite, you forgot the 1 for the 15. It looks like it's 11 over 5.
Oh, I did. No, yeah, I completely forgot that. Thank you. Abigail is up. Okay,
Yeah, I'm
Abigail,
here.
how's it going?
Good, how are you?
I'm good, I'm good. Okay, so this is a little weird, right? I mean, do you see that, like, how do you do that, right? Like, how do you do 11 over 15 divided by 8?
Well, I would just do the keep dot flip.
Yeah, good. Keep dot flip. So can I do this? I'm going to write this for everyone over here. This is what we're really trying to do. 11 over 15 divided by 8, right? That's what we're really trying to do.
Mm-hmm.
And Abigail is saying that we can do the keep dot flip, but before I do that, I want to make sure everyone understands that the 8 is actually 8 over 1. Okay, because we got to be able to, if we're going to keep dot flip, we have to be able to flip the 8. And how do you flip 8? Well, you have to realize that it's 8 over 1, and then it'll flip to become 1 over 8. So here we go with the keep dot flip. Keep dot flip, like that. Okay, so all of what we're doing, all of this right here is this. Okay, Abigail, what do we get there?
I got 11 over 120.
11
And
over
I don't think you could reduce it, but
Yeah, you can't. And the reason you know you can't is because if you look back here to the yellow version, there's nothing that cancels. Like there's nothing that reduces. And because of that, you know, the 11 over 120 is in its lowest form. So here's where we are, 1 plus 11 over 120. Okay, we're almost there. Let's move on to Taylor. Taylor. There's Taylor. How you doing, Taylor?
I'm good.
Good, okay. Following along, everything's okay? All right.
Yeah.
So we've got to add 1 to 11 over 120. How would you do that?
120 times 1 plus 11.
Okay, good. So I think what you're doing, this is what Taylor's doing. She's realizing that this is really 1 and 11 over 120, kind of like a mixed number, right? And then you're doing that little trick where you do the 1 times 120
Mhm.
and then you add that, right?
Mhm.
Good, okay, that will work. So what happens when you do that? 1 times 120, add 11, you get
131.
131, and then over
120.
120.
Mhm.
There you go. Now, just to be thorough here, another way I could have done that, I'm happy with the way Taylor did it. I could have rewritten this as 1 over 1 plus 11 over 120. So just rewriting the 1 as a fraction. And then I could have done that trick that I was talking to Justin about, where you multiply here, you get 120. You add to that here times here, you get the 11, and then over these two multiplied, which is 120, and you wind up getting the same exact answer, 131 over 120. So, oh, was it Justin that I was saying that to? It was, right?
Yes, it was.
Okay. So that's just another option. We arrive at the same answer. Okay, let's do one more. Okay, one more, and I will let's see. So the order now that things are going to happen, just so you know, we got Faith, we got, is it Leah? Leah Gomez? Is Leah here?
That's Leah.
It's Leah, okay. So we have Faith, Leah, Abigail, Abby. Okay, so this is where we got a couple of Abby's in here. So Abigail, Del Rosa, Abby P, Victoria, Denise, Min, and Kiara. So those are like the next 7 or 8 that are coming up. Faith is up though. So Faith gets to pick the next problem if Faith is around. Yep, there's. So go ahead. What do you got? What do you want? Which one of these looks like you don't want to do it?
9.
9? Okay. So let's go with 9. So we have 4 plus 3.2 plus 3 dot minus 1 over minus 1 squared. Okay. All right, Faith.
So the first thing we do is in parentheses, right?
Yeah, sure. So you want to do this one first? That first parenthesis? Okay.
Yeah.
So what would that become?
Sorry.
No, it's okay.
It would become 10.
10, yeah. You do the 3 times 2, which is 6, and then you add the 4, you got 10. Okay, so the top left corner, this is 10, plus, how about the other parenthesis? You want to go ahead and just take care of that right now?
Would it be -3?
-3. So I'm going to put -3, but that's kind of bad notation, so I'm going to put a parenthesis. So the top is going to be 10 plus -3. And then on the bottom, so Faith, I think this is the part of this one that's a little tricky. So what is -1 squared? And let's do this, let's take a vote on this one. Let's use the poll. I haven't used the poll in a while. So the 2 answers that are possible here, if you choose A for the vote, that is 1, and B is -1. And hopefully you're not getting a different answer than those 2. So here comes the poll. I want everyone to vote what answer is correct, 1 or -1. Okay, that's pretty much everyone. So there we go. Here are the results. So 81% of you, 17 of you said that it's 1. And 4 of you, 19% of you said that it is -1. So this isn't to demoralize you or to make you feel like this is why I hate math, but the correct answer is B. It is -1. Now, here's why. When you have a squared, right, you're squaring, the only thing you're squaring is what's right underneath that squared symbol. So you're squaring the 1. You're not squaring the minus that's in front. What I need you to see is this. If I write -1 squared versus -1 in parentheses squared, those are completely different expressions. This one means -1 times -1, and when you multiply -1 times -1, you get +1. So that would be 1. This one on the left, this one is actually -1 times 1 times 1. And I know that that is just frustrating as hell, but that minus sign is really like a -1 sitting in front. And then this 1 squared means 1 times 1. So yeah, I apologize. That's just the way it is, but you have to be careful. All right. That's all I'm getting at is be very careful about whether or not something is in parentheses or not. Here's just another quick example. -4 squared versus -4 in parentheses squared. This one is +16. This one is -16. All right. So with that said, Faith, we'll just let you finish this off. The denominator there is what?
-1.
-1. Okay. Now let's go ahead and put the numerator together. So Faith, when you do 10, you add -3, what do you get?
7.
7. So 7 over -1. And that can be turned into just -7. Because a positive divided by a negative is just negative. Okay, so we don't have enough time, unfortunately, to sit here and go through every single example. You will have an opportunity in your homework to go through some of these, and if you have questions, then of course next class I'll be happy to answer questions. All right, but I think what we've talked about so far, there's nothing in those problems that we haven't discussed. Like everything there is something that we've addressed. All right, with that said, I'm going to move on to the next topic. And the next topic is solving linear equations. Now, I don't think I talked too much about this with you all, but you know, this packet that we're using to do all this, this packet was written by a couple of math faculty at the college. The whole idea was to provide something to students that would be really inexpensive, so you wouldn't have to go buy a $150 textbook. The drawback to this packet is that there's not, if you look at it, there's no explanation of things. It's just here's problems, and then here's your homework. Here's problems, here's your homework. So I have to actually explain things like on my own. So before we actually start solving linear equations, I want us to understand some things, some definitions, okay? So remember, this is all being recorded, so you can always go back and watch this. So don't worry about copying everything down at this moment, but let's just get some terminology in order here. The first definition we have is something called a monomial, all right? A monomial, mono meaning one, it's like one thing, okay? That's what monomial means for us. A monomial is a number times a variable raised to a power. So here are some examples. 4x is an example of a monomial. It's a number, 4, multiplied times a variable raised to a power. Now, what power is that variable x raised to? If it's not written, what is it actually, what's the number that it's raised to?
Is it 1?
It's 1. So if it's not there, it's a 1. Okay? So 4 times x is a number times a variable raised to a power, so therefore it is a monomial. Another example of a monomial, -2 times x squared. You have a number, -2, times a variable x raised to a power, right? So that is a monomial. And I could keep going here, 3/4, and then x to the third. That is monomial. What about that last one? That last one's kind of interesting. Is it a monomial? So do you have a number? You have a number, right? Is it being multiplied times a variable to a power? I don't see a variable, do you? It still qualifies as a monomial, and here's why. You have to imagine that there's actually an x here raised to the 0 power. And anything raised to the 0 is a 1. So it's like there's a hidden 1 next to it. And so it still qualifies as a monomial. So if you have just a number by itself, that's a monomial. If you have a number in front of a variable to a power, that's a monomial. All right, any questions on that? Okay, now, next definition is a coefficient. A coefficient is just the number, oops, sorry, my phone's in my pocket. Let me get this. Turn this on. Okay, the coefficient is just the number in front of the variable. In front, I did not write front. In front of the variable. So basically everything that's in green there, the 4 is the coefficient on the first one, -2 is the coefficient on the second one, 3/4 is the coefficient on the third one, and the 5 is actually the coefficient on the last one. Then the power of the monomial is just the number the variable is raised to. So let me do that in a different color. I've got a 1 there, a 2 there, a 3 there, and a 0 there. Those are the powers, right? Any questions on that? Okay, let's move on to the next definition, and that is what we call a term. So when you have a mathematical expression where you have subtraction and addition separating things, then each of these things that are separated by the addition or subtraction are called terms. So in this particular expression, we would have 4 terms. Do you notice that everything in blue there, each one of those is a monomial, right? They're all monomials, and they're just split up by addition and subtraction. So each one we refer to as a term. Still good? Okay, next thing is what we call like terms. Okay, what are like terms? Like, 2 terms are said to be like terms if they contain the same variable raised to the same power. So in order to be considered like terms, you have to have the same letter and you have to have the same power. So let's look at these examples. On this first example, we have a 3x squared and we have a -4x squared. Those are both considered to be like terms because they both have x squared. It doesn't matter that one of them is 3 and the other one is -4. All that matters in terms of like terms, or when we're thinking about like terms, is whether or not we have the same letter to the same power. Same with the next one, x, x. Forget the half and then -5. Don't worry about that. Just do you see the same letter to the same power? Yes, we do, so they're like terms. Now, the last example are not like terms because they have the same letter x, but they're not raised to the same power, right? One of them is 3, the other one is 2. So these are not like terms. Okay, so why do we need to know anything about like terms? Like, what's the usefulness of that? Well, when we have like terms, we actually have a way of combining them. So to combine like terms, if you want to put them together, all you do is add or subtract their coefficients. So coefficients is a word that we just talked about, right? Coefficient is the number in front. So take a look at this expression. Okay, look at this expression here. Sorry. Take a look at this, these two right there. Okay, so if we look at that, we have two terms, right? Negative 3x squared, and we have another term, 7x squared. These are like terms. They're like terms because we have the same variable to the same power. So if we want to combine them together, all we have to do is take a look at their coefficients and put those together. So if I take negative 3 and I add the 7, I get a 4, and then that becomes my new coefficient, and I just keep the variable squared. So it's kind of like you can only add apples and apples together, and oranges, and pears, right? To be a like term means you're looking at apples, and then it's just a matter of counting how many of each you have. And at the end, you'll have so many apples, right? The next example, same thing. We have 3 terms, right? There's 3 terms. They're all like terms. X to the 4th, x to the 4th, x to the 4th. So all we have to do is identify the coefficients and add them together. So the coefficient on the first one is -2. The coefficient on the second one is -6. And what about that last one? I didn't write it down. There wasn't a number in front of the x to the 4th, the last one. Hopefully everyone is clear or understands that there's always a 1 in front of everything. So there actually was a number. It was the number +1, and that's why I added those all together. -2 -6, or -2 -6 +1, add those together, you get -7, and that becomes a new coefficient. Okay. Now, with all of that kind of, in our toolbox, now we're going to actually talk about solving linear equations. It's already 10:20. What? Okay.
Hey, time flies when you're solving linear equations.
Sure does. I mean, yeah, I mean, they say time flies when you're having fun, and I mean, I can tell this is fun. This is fun. So, all right, so linear equations. Before we get through, because I'm going to give you a set of steps, all right? But before we do those, I just want you to understand the importance of this. I mean, not the importance, but why we do this, okay? So let's say that we have, what if I tell you that if you take something and you add 2, you get 4? Then, what is x? So what plus 2 is 4?
2.
Not a trick question, right? The answer's 2. You can just look at that, right? You can just look at that and get that. You don't have to do any work. You can just say, yeah, 2 plus 2 is 4. Okay, so what if I make it a little bit harder? X minus 4 is 3. Can you look at that and tell me what that is? Like, what number that when you take away 4, you get 3? What would that number be?
7.
7, right? So maybe you can do that one. Okay, what about this one? Twice a number plus 1 equals 11. Can you figure that out? So what number, when you double it and add 1, you get 11?
5.
5, okay. So some of you can get these, and then, some of you might take a little longer. But see, what if I keep adding complexity to it? What if I keep on doing? What if I say 3 times a number minus 5 times that same number plus 4 equals 7 times that number plus 8. Okay, so at this point, you're pretty much done. Like, you're not going to be able to look at that and be like, 6, You're going to have to think pretty deep about it, and, you might get lucky, but it's not obvious. Do you understand that? So in the real world, problems get complicated, and so what we need is a systematic approach, a method to solve linear equations no matter which ones we ever see, we just have a process that we follow, and we'll always get to the answer. Even, you know, so even if we have a simple one that you can just look at and get, that's great, but it doesn't, that method doesn't work for this. So what is the method, right? What is the actual method? Here it is. Okay, yeah, I hope you can see that. So the first thing we're going to be doing, we're solving linear equations with one variable. So it's going to be an equation, and it's going to be linear. So what makes it linear? We didn't talk about that. What makes all of these equations what we consider linear? Linear in one variable. Well, the one variable, is that obvious? All of these only have just one variable in them, x, right? All of those equations have x. There's not an x and a y or something like that. It's only one variable. And the thing that makes it linear is the fact that the powers on these x's are ones. Okay? Remember, we don't write them. We don't write the one, it's understood. So is this a linear equation with one variable? Is that a linear equation with one variable?
No.
No, it's not. And the reason it's not is because that's squared. This is actually called a quadratic equation. And we have a completely different set of steps to solve a quadratic. So all we're doing is we're focusing our attention right now on only linear equations with one variable. If you have a linear equation with one variable, here are the 5 steps to solve it. The first thing you have to do is clear the fractions or decimals. Okay, that's the first thing. And we'll go through these when we get examples. I'll show you how each of these steps takes, you know, how you execute each step. That's always the first step, clear any fractions. The next thing you do is remove any parentheses on both sides of the equation. The third step is to collect like terms, which we've already talked about a little bit now. Once you collect like terms, you'll isolate the variable on one side of the equation. And to do that, you're going to have to add or subtract from both sides of the equation. And then the last step you'll do is you'll make sure that the coefficient on the variable is a 1. And you'll do that by multiplying or dividing both sides of the equation by something. Okay, those are the steps. And now it's time to actually do an example. I'm going to grab these steps and take them with us. Let's do that first one. Yeah, let's do that first one. So let's do the problem that is so obvious that we shouldn't need steps. So let's solve the equation x plus 2 equals 4. Even though we know the answer, all right? So let's talk about the first step. How about the first step? Clearing fractions. So Leah, what do you think about clearing fractions and decimals? What do you think about that step?
It's not applicable.
Yeah, it's not applicable. Yeah, good. I mean, we don't have fractions or decimals. So we can say, okay, step 1's done. No. All right, Leah, what about step 2?
It's the same thing.
Same thing, right? We don't have parentheses, right? Okay, how about step 3, Leah?
Same thing. We don't have like terms.
Yeah, so we don't have like terms, but when we do step 3, we are isolating ourselves. We're going to be looking just at the left side and then just the right side separately. So we look at the yellow and we say, can we put anything there together? Can you add x and 2 together? You cannot, because they're not like terms. You look at the other side, the yellow side, try and add things together there. Well, there's only the number 4. You can't do anything to that. So in this case, when you do that collect like terms, you're looking at left and right hand sides separately. Yeah. Here we can't. There's nothing to do. So we're done with that. So now, let's see. You want to keep going, Leah?
Yes.
Okay, so step 4, isolate the variable on one side of the equation. So what do you want to do here, Leah?
I want to subtract the 2 from the 2 and then from the 4.
Okay, so Leah's saying this x right here needs to be by itself, right? It needs to be by itself. So the way to get the x by itself is to get rid of that 2. And since that 2 is being added on that left side, we must do the opposite, which would be subtract. So Leah, you're saying we're going to take 2 away here, and whatever you do to one side, you have to do the other, right? And so on the left side, this goes away. That leaves you with the x on the left.
Mm-hmm.
You have equals, and then on the right-hand side, you just have to do that, and you get
2.
2. Okay. Step 4 done. Leah, step 5. What do you got? Make the coefficient of the variable a 1.
We don't have to do that. It's already solved.
That's right. There is already a 1 in front of that x, right?
Yes.
There's 1. So we don't need to write it, but it's there. So we're done. And the answer is then x is 2, which is what we knew from the very beginning. All right. But that's just an example how this method works for very complicated linear equations, but it also works for the most simple ones. And that's what you want in mathematics. You want a procedure that works all the time. So I think we've graduated onto harder problems. So let's do number 17.
I have a question real quick.
Yep, go ahead.
So with linear equations, these are the rules, but are we still using PEMDAS?
Yeah, good question. PEMDAS would come into play anytime we have to combine like terms or get rid of parentheses.
Okay.
Uh-huh. Let's see, as we move through this, you'll see when it comes up. Most of the time, PEMDAS is not used for equations, it's more expressions. So if you go back up here and you look at these problems we did, right, all these problems, none of those problems are equations that we're solving for x. They're all expressions. And that when you have expressions is when you really want to focus on the PEMDAS.
Okay.
But yeah, very good question. All right, so let's look at number 17. We're going to take 2x minus 5, x equals 3 times 2x minus 4. And we are talking to Abigail De La Rosa. I know one of y'all sent me an email about like calling you something else, but we'll make this work. So Abigail De La Rosa. Abigail D. There you
Okay,
are.
I'm right here. I think I spoke for another Abby earlier, but
Oh, so you already went?
yeah, but I don't know. You just said Abby, and I just.
Okay, well, let's do this. Since you've already gone, let me get the other Abby. Wait, hold on. How about Abigail R?
It's me.
Okay, you want to do that? You want to go ahead and work this one then?
Sure.
Okay, so step 1, clear fractions or decimals. Do you see any fractions or decimals?
No, sir.
Okay, good. So we can check that off. How about removing parentheses on both sides?
There's a parenthesis on the other side.
Okay, so how do we get rid of that parenthesis? And we haven't really discussed this before.
You can take the 3
Mm-hmm.
and sort of like implement it into the parentheses.
Yes, very good. So what we're doing technically is called distributing. So we're noticing that there's a 3 times something in parentheses. And I'll also point out, you cannot put the 2x minus 4 together. Does everyone agree with that? 2x minus 4 cannot be put together because they're not like terms. So there's nothing we can do in the parentheses to simplify. So Abby is saying, let's take the 3 and multiply it times the 2x, and then take it and multiply it times the minus 4. And that's called distributing. It's also called expanding, but that's more of like, again, like a higher calculus. We always say expand. We kind of don't say distribute as much, but here distribute's fine. So we're going to multiply. So Abby, I'm going to go ahead and leave the left side alone because we're not touching it. And so Abby, what would you get if you distributed the 3 through that parentheses?
Six x minus 12.
6x. And then what?
Minus 12.
Minus 12. Okay, good. All right, Abby. So we've removed all the parentheses on both sides of the equation. We're good. Move on to the next step. Abby, I'll let you keep going. Collect like terms.
You can subtract x 6x from that side and put it on the other side.
Okay, so I think you're one step ahead of the game. I think you're trying to isolate right now.
Yeah.
Think about collecting like terms though. Look at the left side. Look at what's in yellow, okay? Look at just what's in yellow. Can you combine those together?
Yes.
Yes, those are like terms. 2x take away 5x. They both have x, right? To the same power. So what would that be, Abby, if you took 2x and you took away 5x's? What would you be left with?
Negative 3x.
Negative 3x. Okay, so we have negative 3x. Now, Abby, on the right-hand side, 6x minus 12, can you put those together?
No.
No, you cannot, right? Because they're not like terms. So we have to just leave it the way it is. Do you want to keep going, Abby?
Sure.
Okay, so now you can go to the step I think that you were going to do, which is to isolate the variable on one side of the equation. So that means that this is what Abby needs to do. She needs to make sure that she has just x's on one side and anything that's not an x on the other side. And since there's two sides to an equation, which side you actually move your x's to is up to you. You have that freedom. I think Abby wants to get rid of this 6x on this side. That way it's not there. Right, Abby? That's what you said?
Yeah.
So how are you going to get rid of that 6x?
You subtract 6x
So
from
she's
it.
going to subtract, right? Subtract on both sides. 6x and subtract 6x here. It goes away here, which leaves you with the minus 12. And then on this side, Abby, what do you have there? Negative 3x, take away 6x.
Negative 9x.
Negative 9x. Okay, good. I'm going to go ahead and just let you finish it, Abby. I mean, you've gone this far.
Then you divide negative 9 from both sides.
Good. So now the goal is to try and make the coefficient in front of the variable a 1. Right now it's a negative 9. We need to get rid of that negative 9. And the only way to get rid of that negative 9 that's being multiplied is to divide both sides by negative 9. And negative 9 divided by negative 9, that gives you a 1. So we actually have 1 in front of the x. And on the right-hand side, a negative divided by negative would be positive, right? So we should have 12 over 9. But that fraction actually reduces, right? 12 over 9, 3 goes into both of those. And I'm not going to write the 1 in front of the x anymore because it's understood that it's there. So we should get 4 over 3. There we go. Good job, Abby.
Yeah.
Okay, so let's just go back and think. Earlier, when I first started this, I said, if I write x plus 2 equals 4, you could just look at that and be like, oh yeah, x is 2. But if you have more complicated problems, you can't do that. Like this problem here. This is like me saying, hey, take a number and double it, and then take away 5 times that number. Whatever you get there is equal to doubling that number, taking away 4, and taking that whole answer and multiplying it times 3. What's the number? Well, it's 4/3. But the only way you arrive at that is by doing the systematic steps. This all makes sense? I know that most of you have done solving linear equations in your life at some point, okay? But you know, if you haven't done it in a while, you kind of like, you know, it's easy to lose some of the sharpness that you have there. Let's move on. I'm gonna pick a problem here that has fractions in it. I'm gonna do number 23. All right, let's see where we are here. Okay, we actually have Abby P now. So where's Abby P? Is Abby P here?
I'm here.
You there? Oh, there you are. Okay. All right, so Abby, first step. It's okay. We can handle it for a little while. We're all adjusting to this new reality, right? So I think we can all handle it. So we're going to try and clear the fractions, right? That's the first step. So we actually have fractions for the first time. So when we clear a fraction, Abby, are you familiar with it? You know what? You seem stressed. Do you want me to just come back to you another time? Or?
No, you're okay.
Okay. Okay. When you see the fractions, since this is our first time doing it, what we're going to want to do is look at the denominators of all the fractions on both sides of the equation, and from that, find an LCD. So can you tell me what the least common denominator would be? So out of 5 and 7. Did you say 35?
Yes.
Okay, yeah, 35. Okay, now here's the thing, everyone. Pay attention to this. This is an important point. We are not going to try and turn these denominators. Oops. We are not going to try and turn these into 35s. That is not what we're going to do. What we're going to do is we're going to multiply both sides of the equation by the LCD. That's the technique that you always use when you're clearing fractions. So what I'm saying is this. We're going to take the original. Let me just, I don't want to have to rewrite it. Nah, I'll rewrite it. We're going to take the original equation. Now that we have identified the LCD, we're going to take the whole left side and multiply it times 35. And then we're going to take the right side and also multiply that by 35. But notice my use of parentheses here. Okay, now you might ask yourself, why are we going to do this, right? Well, if you do this step, when you multiply the 35 through, you will no longer have fractions. Everything will be nice numbers. So let's move and do this distribution. We're going to multiply here to here, here to here. And then after we do that, we're going to go here to here, here to here. So Abby, I'll go back to you. Is this making sense?
Yeah, so far.
Okay, so I want you to do the right side first because it's the easier of the two. So what would happen if you distribute the 35 through that parentheses? What would you get?
35x minus 35.
Yep, okay, good. Now the harder part is the left-hand side. So Abby, let's just do this. If you did the 35 and you distributed it to this, what would you get? I'm just curious how you are processing that. You're trying to do 35 times 2 over 5x. That's what you're trying to do.
Mm-hmm. Wouldn't you do like the 35 over 1?
Good.
Like make, yeah.
Excellent. Yep. So you're going to go 35 over 1 times 2 over 5x. And then do you just want to multiply across? Is that the way you would do it, or would you reduce before the multiplication? It's really up to you.
Oh, you could reduce the 35 and the 7. I mean the 35 and the 5.
Do you want me to do that way?
Yeah.
Okay, let's do that. So you're saying that 35 and 5 goes into both of those, right? So 5 goes into 5 once, and 5 goes into 35 7 times?
Yeah, I think so.
Yep. I think so too.
And then multiply like the 7 and the 2, and then the
7 times 2, that gives you 14 over the 1 times 1 gives you 1, and then you have the x still. So you just get 14x, right?
Yeah.
That's it. Okay, so that's what our first multiplication would be. And then we have minus, right? Minus. And now we have to do it again, but we've got to do 35 times 5 over 7x. Same thing, we can write 35 as 35 over 1.
Mhm.
And it reduces again, doesn't it?
Yeah, with the 7 and the 35.
Yep. 7 goes into 7 one time, 7 goes in 35 5 times. And then when you multiply straight across that time, you get what?
25 over 1.
25 over 1, and then you still have the x, right? So just 25x,
Yeah.
and that's it. So notice what we've done. We took an equation that had fractions, and nobody likes fractions. And we did step 1, which was to clear the fractions. We found the LCD, we multiplied both sides by the LCD. It was a little complicated, but look at the end of it now, we have no fractions. So now we can move on to step 2. And Abby, I'll take you off the hook. We'll go to Victoria. I'm almost out of time, but I want to finish this problem. Victoria? So it's Victoria.
Yes.
Okay, Victoria. Step 2. Do we need to do anything for step 2?
No.
No, we don't have any parentheses. So step 2, we can not worry about. How about step 3, Victoria?
Yes, you can take away 25 from 14.
So those two are like terms, so we can put them together. So what is 14 apples take away 25 apples? How many apples you got left?
Is that negative 11?
Negative 11, right? And then on the right side, can you combine those together or no?
No.
No, you cannot. All right. Okay, so it looks like we've got step 3 done. We have collected like terms. All right, you want to keep going, Victoria?
Yes.
All right, so isolate the variable. So how would you do that?
I would subtract 35 from the
35x,
yeah.
right? 35x,
Yes.
and that's got to be from both sides.
Yes.
Goes away here. So what would we be left with on the left side? What would we have?
Negative 46x.
Good. Yeah, negative 46x. And on the right side, we have
Negative 35.
negative 35. Let me just ask you something real quick, Victoria.
Mm-hmm.
Let's say that on the right-hand side, I'm going to highlight it here. What if that had been a negative 35x on the right-hand side, and you wanted to get rid of it? What would you have done to both sides instead of subtracting 35x?
You would add it.
You would add. Okay, so the only reason we're subtracting there, everyone, is because the original problem had a positive 35x, so we took it away. If it had been a 35x, we would have added it. So you're always going to be doing the opposite of what you see. Okay, almost there, and we're almost out of time where we are. But make the coefficient a 1. What do you got?
So you would divide by negative 46, both sides.
Both sides by negative 46. Cancels out. You get x equals negative divided by negative is positive, and that might be the answer. It might reduce. I don't think it does though. So we're just going to box it up. Wow. Okay. So as you can see from this, solving linear equations, it's very systematic, right? It's very just follow the steps, but there's lots of room for making mistakes. So what you're going to need to do is look at your homework. You should be able to do page 13. You should be able to try all these problems, all right? And then you want to start looking at this second part, part B of the homework on page 14. I would say go for it, you know, see how it goes. The only problems we haven't really talked about are problems 20. We haven't done a decimal yet. 35. Otherwise, the rest of those you can at least try. I think you might have some trouble, but see how it goes. So don't do 20 or 35 unless you really want to. Oops, what did I just do? How do I do that? Okay. Yeah. Okay, so for homework, is that clear? Page 13, part A, do everything there. And then 14, part B, do everything except 20 and 35. And we will start class next time, I'm sure, with questions. All right, we good? Thank you for your attendance and your participation. I appreciate it. Test is going to be a week from this Thursday, right? Just so we're clear, everyone knows that. All right. Have a good one. See you Thursday. I'll hang out if you have any questions, okay? If anyone needs to talk to me, I'll hang out.
Okay. That last one, do you mind going back to it?
Yep.